In today's lesson, we're going to learn about finding slope. Slope is a ratio that describes the tilt or slant of a line. It's known as the change in y coordinates over the change in x coordinates. It's also known as the change in y over the change in x. You can also see the formula, which is y sub 2 minus y sub 1, all over x sub 2 minus x sub 1, or it's also known as rise over run. So it takes many forms and many shapes, but we're going to go ahead and use it here. Method number one to find a slope given two lines is going to be plotting those points on the graph, then counting rise over run. So I'm going to go ahead and highlight my first point here. I'll highlight it in pink because I'm going to go ahead and place that point at 0 for x and 3 for y. Remember, your first coordinate's always your x, and your second coordinate's always your y. Then I'm going to go ahead and highlight the second one in a different color to show you that I'm plotting this point of 4, -2. The x is 4, the y is -2, so that would be located here. Make sure you plot your points correctly. After plotting the points on the graph, the next step says to count the rise over the run. That's exactly what we're going to do here. Rise is going to be talking about when I'm moving up or down on the graph. Think about like an elevator, that's your rise. An elevator only go up and down. The run is going to be talking about your left and right. Because again, when you're running, you can run left, you can run right, but you have to be running on kind of a flat surface. You don't just rise up or down off the ground. So that's exactly what we're going to do. I'm going to go ahead and mark the rise as my green here to kind of count it down. So I'm going to go from this left point to the right, down 1, 2, 3, 4, 5. So that's going to be talking about down 5. When I go down 5, if you see I'm getting to more negative numbers, so I'm going to put a -5 there as my rise. In the denominator, I'm going to go ahead and put my run, which is going to be running to connect to the next point. 1, 2, 3, 4. I went to the right 4. Notice on my x-axis, those numbers are getting more positive. So right is going to be a positive movement. From here, I just take the actual numbers to write my final answer, which is going to be my slope of -5 over 4. Let's go ahead and try method number 2. So if you're given 2 points, maybe you don't have a graph, or maybe you want to try a different method, you can use the slope formula, which we have written up here. M equals y2 minus y1 over x2 minus x1. It's so important that you go ahead and make sure the y values are in your numerator of this formula. What I go ahead and do is label my y1 and y2 as well as my x1 and x2. For my points here, it's always going to be x comma y for each set of points you have. I'll label my first points with a little subscripts of 1 to identify that it's on the first ordered pair. And I'll write little subscripts of 2, identifying it's on the second ordered pair. That way I know the difference between the two. Y2 gets replaced in Y2, so that would be 5. And I subtract Y1, which is 1. I put it over my denominator, which is x2, replacing it with the -2 it's labeled as. I keep this subtraction, and I put in a -1. From here, I evaluate the numerator down. 5 minus 1 is 4. I also want to simplify the denominator to one number, and -2 minus a -1 is just another way of saying -2 plus 1. Those two negatives make a positive. That's going to come out to be -1. I always want to simplify the fraction if possible, and 4 divided by -1 is -4. My final answer for the slope here. Let's try those methods again. So again, given 2 points, I can plot them on my graph here. I go ahead and make one of them here in green at the x value of 6 and the y value of 3. When you plot that point correctly, it should match where I'm putting my green dot there. When you plot the next point of 8 comma 4, again make sure the first value is your x, second is your y, and you should have plotted that point at the pink dot on my graph. Remember that you have rise over run here, and rise is talking about the up or down movement, whereas run will be your left and your right. So I go ahead and count from here. Up 1. When I go up 1, I know that's going to be a +1 in the end. Then I go ahead and count how far over I have to go to connect the point. Remember, my only movements are up, down, left, or right. So I'm going right 2, which is getting to more positive numbers. So I have a +2 here. I just take the numbers for my final answer, which is going to be a +1 over 2. In a calculator, you would get a decimal for that. Make sure you leave it as a fraction. What is the slope between, for example, for -5 comma -2 and 5 comma 8? So again here, I have 2 points. I can plot them on the graph and count rise over run, or I can use that slope formula. M equals, remember y is in the numerator, subtracted from each other, and the x's are in the denominator, subtracted by each other as well. We go ahead and label our points. I have an x1 and a y1 and an x2, y2. I go ahead and replace them in my formula in the proper locations. So where I have y sub 2, I put 8. Where I have y sub 1, I put in -2. And don't forget to keep the negative sign between them. In the denominator, in place of my x sub 2, I put 5. In case of my x sub 1, I put -5. And don't forget the subtraction between them. That must stay. What we do now is actually this combining of the numerator 2 numbers and the denominator 2 numbers. So the top comes out to be 8 minus a -2, which just means 8 plus 2, which is 10. And then 5 minus a -5, which is just 5 plus 5, 10. 10 divided by 10 comes out to a simplified 1, and that's your final slope. So again, you have 2 methods to choose to find slope when given 2 points. You can plot them on a graph and count rise over run, or you can label each one correctly with an xy, xy, and make sure one has a subscript of 1 and another one has a subscript of 2, so you can tell the difference when you're plugging those numbers into your slope formula. So we're just talking about slopes, and for a sketch, a positive slope is always going to be one that rises from left to right. Just like how we read left to right, this one is rising from left to right. A negative slope is going to be when I am decreasing, falling, going down from left to right. So again, just like I read, it's now falling, going down, decreasing from left to right. An undefined slope is always, always, always going to be a vertical line. Let me draw a little bit better vertical line here. I'll use a tool to help me out here because you want that vertical line perfectly up and down. Put arrows on both ends showing it goes on forever. And that is always a vertical line having an undefined slope. For a zero slope, that's going to be one that is horizontal. So again, I'll use a tool to make it a nice straight horizontal line here, putting in arrows on both ends to show it's going to go on forever, having a horizontal slope. To help us remember, the next case to find slope is when we're given a graph. The steps are going to be count rise over 1 from 2 nice points on the given line. Nice points, for instance, in this example that's already done for us, are going to be ones that fall perfectly on an x and y value. So see, this point falls perfectly on -4, -2. This point falls perfectly on 3, 3. But notice at this point here on the x-axis, it's a decimal and falling just shy of -1. Same thing here on the y-axis. The point is so close but just shy of 1. You can also keep going with any point between the two because it's not going to be a perfect point. It would be a decimal, not perfectly lying on a whole number for the x and the y. It's really great, this key over here, to remember that if I move up and right, those directions will always give me a positive number. When I move down or left, those movements will always give me a negative number. So in this example done for us already, we count up from our first point: 1, 2, 3, 4, 5. And because I counted up 5, let me use the right color that we have over here that they use, which was a blue for the rise here. A rise of 5, and it's a positive 5 because you went up. Then we go ahead and run in red to the right. 1, 2, 3, 4, 5, 6, 7. That connects our 2 points together. Again, remember, you can move up, down, left, or right. And because we moved right with our run here, that's why it's a positive 7 located in the denominator. I cannot simplify that fraction anymore, so I leave it as 5 over 7. Let's try one together. We want to find the slope of a given line, so I go ahead and find 2 nice points. I have one really nice one here at 0, 2. I have one really nice at -3, 0. I have another nice point at 3, 4. Any other point on this line would give me a decimal point or answer, which I do not want to use. So I can choose 2 of these points. I'll do the first 2, so I'll erase my last one. To count rise over run. So my rise is going to be up from this point 2. That's going to get me in line with my next point to help me connect the run. Because I went up 2, that's going to be a positive 2. I then go ahead and connect my 2 points together with moving to the right 1, 2, 3. Since I moved right 3, that's going to be a positive 3. Now, what's really cool about this is that what if you decided to count differently? So what if I decided to count from my right to my left point? Well, here's what you would get. Counting from the right point, I have to go down 2 to get in line with my left point. Since I went down, that's going to end up being a -2. Then I go ahead and have to connect my points by going left 1, 2, 3. And since I went left, that's going to be a -3. The cool thing is that when you simplify either of these fractions, 2 over +3 or -2 over -3, you will still get the final answer of 2/3. So it's really cool that you can count either way. Just make sure you do one or the other. Let's go ahead and look at our next example 6. First step is always finding those nice points. So I got a nice point at 0, 2. I got a nice point at -1, 4. I have a nice point at -2, 6. I could keep going with a nice point at 1, 0. I got a nice point at 2, -2. And a nice point here at 3, -4. So that's way too many points that I need. I'll choose the first two on the left. But just to let you know, you could choose any of those and get the right answer. Any other point, you could not get the right answer. So we go ahead and count the rise here. So I go from left to right by counting down 2. That's going to get me in line with my point. Not quite there. I'll use the run to get there and connect them. But I go down 2, which means I got to make it a -2. I'm going to run to connect my points, and I only have to run 1 to the right. Because I run 1 to the right, that's going to be a +1. Again, use that key at the top to help you determine what movements are positive and what movements are negative. That's going to be the fraction I use here, just the numbers. So I have -2/1, which is just dividing to be -2. The cool thing is that I could also count from the right point to the left. So if you had counted from this right point up 2, it's a +2 because you went up. And then you could run to the left 1. And left is a negative movement, so that's going to be a -1. You still would have simplified to the same answer. You would have had +2 over -1, which still simplifies to the -2 final answer we have circled here. So it's pretty cool. You could count either way to get it right. Now let's do a recap on what we learned so far before moving forward here. A review on slope. Slope is going to be our rise over our run here, also known as the slope formula of y2 minus y1 over x2 minus x1. We can use both of those to have us solve all of these here. On the graph, we just did that. We find two nice points. So I have a nice point at +1, 0, 1, and a nice point at 4, 4. You can have other nice points on this line, but those two work. Another nice one, just to let you know, is here, but no other options you have. I'll go ahead and do the first two I put in, though, counting my rise over my run. I go ahead and rise up 1, 2, 3. I know when to stop my rise when I am perfectly horizontally in line with my second point. So I went up 3, and remember, up is going to be a positive movement. Then I go ahead and count right in this case 1, 2, 3, 4. So up 3 and right 4. And because right is a positive movement, I'm going to go ahead and have a +4. From here, I simplify that fraction down. I take the +3 and divide it by the +4. When it comes out to a decimal, please just leave it as a fraction. So your final slope answer for this one is 3/4. For the second one, you can plot those points and count rise over run, or you could use the slope formula, which we have above. The slope formula is m, which is the letter for slope, equaling y2 minus y1 over x2 minus x1. Again, this m just means slope. I don't know why they chose that letter for it, but they did. From here, I'll go ahead and highlight and label my x, y, x, y. I'll make the first one with subscripts of 1 to differentiate it from the second point with subscripts of 2. I plug into my formula y2 first, so that's where my 5 is going to go. Then I go ahead and plug in my subtraction I keep of y1, and y1 in this case is 2. I go ahead in the denominator plug in my x2 first, which is going to be 10. And then I plug it in after subtraction. Keep that subtraction. So these subtractions here and the division symbol I'm keeping. I'm just changing every other part to the number, and my x1 in this case is going to be -8. I just plugged in everything else I knew, my y2 of 5, my y1 of 2 after that negative, keep the negative, my x2 of 10, and then after the negative, my x1. From here, I solve this down. 5 minus 2 comes out to be 3. And then 10 minus a -8 is a great way of just saying 10 plus 8, and that's going to be 18. I want to simplify this fraction, 3 over 18. I can do so in Desmos. I can also do so by hand by seeing that 3 divides by 3, and so does 18. 3 divided by 3 across the numerator comes out to be 1. And 18 divided by 3 in the denominator comes out to be 6. Again, you never want to leave slope as a fraction. You want to leave it as you want to leave it as a fraction, not as a decimal. Just making sure you knew that. 1 over 6 is my final simplified slope for this example. When we have a table, we have to do a little bit different. We have to go ahead and find the slope. Remember, the slope has the letter m, which will be our change in y over our change in x. That came right from the front of our notes describing what slope is. Well, let's look at the change in y. Change is how I get from the first value in my table to the next value of my table. In order to get from -1 to -3, I have to subtract 2. In order to get from -3 to -5, I have to subtract 2. In order to get from -5 to -7, I have to subtract 2. And in order to get from the last terms in my table, -7 to -9, I have to subtract 2. You want those to all be the same. If they are not, they will still simplify to the same slope as long as they're making a line. So that's what's pretty cool. We go ahead and look at the right side here. Well, that was the right side. Let's do the left, my x's. The change between my x's, how I get from 4 to the next value of 5 of my table, is +1. How I get from 5 to 6 in my table, the next value is +1. How I get from 6 to 7 is by adding 1. And how I get from my last two values of 7 and 8 is adding 1. So we go ahead and put that in our slope formula case. Slope, again, you can use the letter m for it, is going to be the change in y, so that was -2 here, over the change in x, so that was +1. The biggest thing you have to remember is it has to be y in the numerator and x in the denominator. What's really cool about that is if we look back to our formula up top here, it was the same idea. We had to have y over x. We go ahead and simplify this fraction. -2 divided by +1 is a -2 slope overall. So my hint to you is if you can divide without getting a decimal, do so to simplify your fraction. If your division ends up in a decimal, just leave it as a fraction. For the last 3 problems in our notes, it says try it on your own. So at this point, you can pause the video, read through the steps and try them on your own. And then you can come back here because I'll be going through them. But if you're really lost, you can just keep following along. Remember, for a graph, our first try it on your own question, you're finding nice points on the graph. So that's here at -1, 5. That's here at 0, 2. That's also here at 1, -1. You can count from any of those points, none others on this graph that we can see. And I'm going to choose the first 2 I plotted. Again, I count my rise, which will be from left to right, falling down 1, 2, 3. Again, because I went down 3, that's going to be a negative operation. So I'll put a -3. I know to stop there because it is perfectly in line with my point. I just have to do some run. For my run, always goes in my denominator. I just have to move to the right 1. Again, because I moved to the right, that is a positive operation. So I'll have a +1.